Now we're doing section 2.6, number 13. And we've got to find the limit as x goes to plus or minus infinity of f of x. And here's our f of x. Well, first I want to cover something. Consider this. What if I had the limit as x goes to infinity of 1 over x? Will you agree, well, let's think of this. Will you agree that's going to be 0? And you can say, well, how do I know that? Give me an example. Well, okay, let's let x be 1 over, like, 10 to the 20th. That's a 1 with 20 zeros. Will you agree that's darn small? And this is going to get, this denominator is going to get larger than that. Would you agree that's essentially darn close to 0? Okay, what if we look at the limit as x goes to negative infinity of 1 over x? Well, I'm going to claim that's going to be 0 also, because we're just talking about on the way to negative infinity, and we never get there. We'll stop by 1 over, negative 1 over 10 to the 20th, which is darn close to negative 0, which is still 0, isn't it? This doesn't equal 0, but it's darn approaching it, So with that concept taken care of, now let's look at this guy. So we're going to take the limit as x, and this is a, as x goes to infinity of 2x plus 3 over 5x plus 7. Now what you do is, look, the degree of this denominator is 1. So we'll look at the limit as x goes to infinity, and what we're going to do is divide every term by x to the first power, because the degree is 1, plus 3 over x and 5 over x divided by x plus 7 over x. Now these divide out, those divide out, but this is going to go to 0 by what we just did over here. This is also going to go to 0, and so what do we get out of this thing? Well, we get 2 over 5. Okay? Now, let's look at what's going to go on as the limit as x goes to negative infinity. And again, I'm just going to dive right into it this way. We still have 2x over x plus 3x over x when we divide every term by x rather than start from scratch. 5x over x plus 7 over x. By what we just did over here, this term is still going to go to 0, and this term is still going to go to 0. We already wrestled that to the ground. And these x's divide out, and we still get 2/5. So now we found the limit as x goes to plus or minus infinity of f of x. Okay, now we're doing question 43, and we have to find this limit. And I'd encourage you to look over example 12 before doing this. So let's go ahead and graph this. And let's see. We've got a vertical asymptote at 7. And so there's our vertical asymptote. And as x approaches 7, by the way, we have a y-intercept of 4 over 49, letting x be 0. So that'd be way over here. But so if we graph this, it's going to look like that where this point right here is 0, 4 over 49, and it's, you know, it's going to go on forever, and going to go on forever and be approaching 0, never quite get there, but always approaching. Now, the reason it is graphed like this is because this denominator is always going to be positive because it's squared, and the closer we get to 7, the difference between these two values will be smaller and smaller. I mean, it'll be like 1 over 10, 1 over 100, 1 over 1,000. And when you invert and multiply, then you'll get 4 times 10 is 40, 4 times 1,000 is 4,000, and so on. So it's going up forever. And so the limit, then the limit as x goes to 7 of 4 over x minus 7 squared is infinity. Both sides going in the same direction, going to infinity. Okay, now we're doing question 67, and it asks us to graph this thing. And if we graph this, we've got vertical asymptote at -2. And the horizontal asymptote at 1 when we take the limit as x goes to plus or minus infinity. By what we did in the previous problem, we're going to get 1. And so here we are at 1 and horizontal asymptote. Now let's find the x and y intercepts. Well, the x-intercept for this is going to be at, what'll take this to 0? -3 will. So -3. And what's the y-intercept? Well, the y-intercept is going to be 3/2, which is 1.5, because we let x be 0. So here we are at 0, 3/2. And this is -3, 0, by the way. So what does that tell us? Well, this is the shape of that graph then. And okay, now we've got that much done. And then the next question is, well, what are the dominant terms? And if you look on pages 113, 114, you'll see about that. And they talk about dominant terms, and I can break this up into 2 terms by writing it as x over x plus 2 and 3 over x plus 2. And so x over x plus 2, it's dominant when x is going to plus or minus infinity. When x is going to plus or minus infinity. Because we will wind up getting just 1, and that gives us our horizontal asymptote. 3 over x plus 2 is dominant when x is approaching 2 from above or below, because when x is approaching 2 from below, we're going to negative infinity. When x is approaching 2 from above, we're going to positive infinity. So, and we're done. That takes care of it.